All right, this is 3-1. Today we're starting our unit on functions, relations, and functions. All right, so tonight you're doing page 108 in the Big Ideas book, number 1 through 42. All right, in a real-life situation, a little background. Beta drives at 45 miles per hour. She pulled over at a gas station to look for her purse. She then raced home at 60 miles per hour to find her purse. Graph her distance from home over time. The first thing we need to do is decide what to name our x and y axis. So to do this, I have to ask which quantity depends on the other. So if you look at, if you look at this over here, it's asking us to graph her distance over time. Okay, and so I ask myself, does distance depend on time? Or does time depend on distance? Since the further you go depends on how much time you put in, your distance would be your depender, and that goes on our y-axis. And then we've got our time, which goes on our x-axis. Now, if it's time, it's generally always going to be on the x-axis. Now we start to use the story. As she's driving, she starts from home, the origin is home, and she's increasing at 45 miles per hour. Then notice she pulls over in her car. What happens, John?
She stops, but the time is still going.
The time increases, but the distance doesn't, so what happens to the graph? Yeah.
It goes horizontally.
Goes horizontally. Then she looks in her purse when she realizes she can't find her purse. She looks in the car, and so she rushes back home to go see if her purse is home. And she heads back, and what's the graph going to look like, Nicole? A steeper slope, and it's going down because the distance is decreasing. Now, this is what we call, because every minute we're graphing it, this is what we call a continuous line. Generally, with time, you will have a continuous line. Now we're looking at the next one. Martha will put a quarter in her piggy bank every day, starting Monday, except on weekends. Graph her total savings over the first 10 days. So again, I ask myself, does savings depend on time, or does time depend on savings? Because the depender goes on the y-axis. So our savings depends on how much time I'm saving for. So savings is on the y, time is on the x, and we're doing it in days. Now, where would my starting point be? How about Gohar? Where am I starting on this graph? At the origin with a point. 0 days, 0 money, 0 savings. Now, Caleb, what would the next thing look like if I went to go graph this situation?
It would go to 25 cents, so it would go in the
So he's saying a diagonal line to
halfway.
1 day at 25 cents. Agree or disagree? So you're telling me, now here's something you've got to think about. If I'm writing a line, okay, if I make this a line and I'm making this a point here, right? That means at a half a day, am I depositing? Because I've got a point there. If there's a line, there's a point there. Does that make sense? And what about at 3/4 of a day? Am I depositing? So I don't put the line. I show this instead with just a point. Because I'm only depositing one time a day to the piggy bank. Does that make sense? Yes or no? Okay. So on day 1, I put a quarter in. Boom. Day 2, I put another quarter in. I'm at 50 cents. Day 3, how much? Day 4, $1. Day 5, day 6, but I'm still, is my time increasing? So I still go there. So what's my line going to look like? What's going to happen? Hike? What? It's going to get horizontal, right? The pattern's going to start to look horizontal. Day 6, it's still 125. Day 7, day 8, 150. Day 9, day 10.
$2.
Okay. Now, and I can say this pattern will continue. We can put a little arrow as that last one. We can say like that. We can do the little arrow here. We wouldn't put the arrow in this situation because the pattern's not. They said 10 days. That's it. But this is what we call a discrete line. When I'm not utilizing all the time in between here. Does that make sense? I'm not sitting at the piggy bank waiting to put a penny every second. Does that make sense? Okay, so continuous is a straight line, and it's utilizing all the time in between. Because the second I leave, I'm using time. So I would need that. Generally, when you have time, you will have a line. But if you have something where we're comparing quantities, it's going to be discrete. Does that make sense? All right, so let's look at actually some new definitions. A function is a rule that describes a dependent relationship between two quantities. Another new word is the domain. What does this mean in kid words? The set of input values in a function. What am I talking about, Caleb?
Means like the numbers that are within your function or what are the range.
Okay. What else can we say about our inputs? Where is that in the table? What are those? Chris.
X.
These are your x's. Your domain is your x's. This is, we can write these in a couple different ways. We can call the domain our inputs. We can say these are our x's, our x values in the ordered pair. And we can also say that this is our independent variable. Okay? And our range, on the other hand, is what values?
Y.
You should be writing this. Y values. And these are our outputs. And these are the dependers. So they're dependent. If time is involved, generally that is independent. That's how I know to set up my graph. Can I move on?
No.
Nicole, question.
On the end of our graphs, do you have to put arrows?
For the x and y axis, yes. Can I move on?
No.
Look at a model situation. Okay, I'm going to say n represents number of triangles, and P stands for perimeter. Okay, so if I were to create a table of this pattern, what depends on the other in this situation? Does perimeter depend on the number of triangles, or does triangles depend on the perimeter? Daniel in the back? So when I set up my table, what's my dependent? Everybody?
Perimeter.
Perimeter, P. And what would I put in my X?
Number of triangles.
Number, N. So, can I not say, notice that I have one triangle for the first one, and one triangle gives me, now each one of these sides is one unit. Okay? So, right here, we've got 1 unit. Okay? So I've got 1, 2, 3. So for one triangle, I have 3 units of perimeter. What about for 2 triangles? What's my perimeter? Ian?
6.
Be careful. Perimeter is the fence. The fence surrounds the outside. So it would be 1,
2,
2.
3, 4.
So for 2 triangles, it's 4. What would 3 triangles be, Slil? Okay, let's count it out. Where are you getting 6 from? 1, 2. So we said for 3 triangles, 3, 4, 5. What about 4 triangles, Slil?
6.
Okay, could we predict 5, Tony?
7.
And what about 6, Joseph? 9? Where are you getting your prediction? 8. Where did you get that from? How do you figure it out? What? You're adding 2 to n, right? It's the triangle plus 2. Gives me the perimeter. Number of triangles plus 2. So we could actually write that. Perimeter is equal to what? N plus 2. There's our equation. All right. Now, I could graph that. Would this be continuous or discrete?
Continuous. Oh, discrete.
Why?
Because you can't have like half of it.
Why would it be discrete? Why would it be continuous? What do you think? Nicole? Nobody says that the pattern can't continue. Because continuous and discrete do not mean that the pattern continues. The pattern can continue with either of those. The difference between, who can clarify when we use continuous? Okay, Caleb.
I think discrete is when
What do you think it is, Caleb?
I guess continuous is when it just goes on and there's always a possible solution. But whereas discrete is either there's no nothing that it's like close for a certain amount of time.
Okay, Daniel L.
I think continuous is when it like doesn't stop, but discrete is like.
They both can go on and on in this direction. Discrete and continuous can go on. Zach.
Continuous utilizes all the time.
All the time. And what about in this situation?
It's always continuing at the same rate, so it's using all the time.
Okay, so what you were not thinking of, guys, Ian said it. Ian, I think it's Ian or Chris. Somebody blurted it out here. What is it? Discrete or continuous?
It's discrete.
Why is it discrete?
Because continuous is when it constantly increases, and discrete happens only like
In increments.
yeah.
Can you have half a triangle?
No.
So it has to be at one triangle. This has to be discrete because I'm never going to have half a triangle or of a third or a fourth. Do you understand? It's not utilizing these units in between. Whereas the other one we were talking about time. As time's increasing, every second we're utilizing that. Here, I'm only plotting with one triangle, I have 3 units. With 2, I have... Does that make sense? When to use discrete. Now look, this discrete goes on and on forever. Is that clear? It does continue, this pattern, but I'm not utilizing these in-between areas because I'm not going to plot 1.5 triangles. Does that make sense? All right. And then we said we could come up with the equation. Now, another thing, I want you to take a look at this table here. We could write that table like this. Let me put it here. I got to do it so you guys can see it. I can write that table like this. I can write it as, what is this 1, 3? It's really an ordered pair, right?
Yeah.
So I can write this whole thing, I call this 1, 3, 2, 4, 3, 5. This is a relation. This is a table. Whoops. The other is a table. Does that make sense? When I put them in ordered pairs, they're a relation. In a table, it's a table, but it's the same information. Does that make sense? Okay, I'm going to skip this one. Okay, now we go back to our domain and range. Remember, a relation is any set of ordered pairs. Our domain is our input values, or our x's, or there are independents. Our range is our outputs, or our y's, or our dependents. What is the domain for this relation? What is the domain for this relation? Who can tell me what state the domain? John?
2.
2? Is that the domain? Gabby? Yep. 2, 3, 4, 5. I take all the x values. Didn't we say it's our inputs, it's our x's? You should be writing this. Range. John. What is the range?
The range is 5, 7, 9, and 5, 7, 9, and 11.
Now remember, this is like elements of a set. Same thing. Our range, these are the range elements. Here's the relation, here's the domain, here's the range. Okay, you guys try number 2. Go. I'm so far behind. Okay, so the domain is -3, -2, -1, and +1. What is the range? Now again, remember this is like members of a set. Willie.
The range is 10 and 6.
10 and 6. I don't need to write the repeats. 10 is the range, 6 is the range. Usually we go from least to greatest. I know my PowerPoint doesn't do that. Now, can I move on? Okay, now we said a relation is any set of ordered pairs. Here is another definition that they use quite often, but this confuses me. A type of relation where there's exactly one output for every input. For every x, there is exactly one y. So in kid words, I like to say no repeated x's. No repeated x's. That means in your table, you should not see an x value being repeated. That's what that means. For every x, there's exactly one y. There's only exactly one output for every input. So here's an example of a table. Would this be considered a function?
Yes.
Are there any x's that repeat?
No.
So if there's no x's that repeat, it's a function. It's a function. This is something called a map. Now, basically I take all the members of the input or the domain and I list them in this oval, and I take all the members or elements of the range and I list them, and then you'll draw little arrows. What does 1 go with? 6. What does 2 go with?
7.
What does 3 go with?
7.
There we go. And so basically, what this is saying is that I can actually, let's pretend I didn't even have the table, and they just gave me the map. I can create the relation. It means 1, 6, 2, 7, and 3, 7. Do you see that? This is the relation. This is the map. And this is the table. 3 ways to write the same thing. So tonight in your homework, if they give you a table and say, show me 2 other ways, then you can show the map and the relation. Or if they give you the relation, you can show the map and the table. Questions? All right. So now, you're not always going to have to write the map, but what you have to know is how to read the map. Okay, here's another table. I'm going to draw the map. My members are 1 and 2. My range is 6 and 7. 1 goes with what?
6,
And 1 goes with what?
7,
And 2 goes with?
7.
Now, is this a function?
No.
Why not, Jairus? There's 2 outputs for 1 input. Whenever you have this scenario where there's 2 arrows coming out of an input, it's not a function. In the table, how does it look? How does this look in the table? Something that's not a function. What are we seeing there? Slil? The ones are repeating. When the ones repeat, it's not a function. Is that clear? What's the rule? No repeated x's. Okay? Now let me show you a real life scenario of this. Sometimes I'm traveling with my son and we want to stop at the 7-Eleven, and we walk into the store. And in the store, you've got 3 different kinds of gum. We'll say 1 stands for Double Mint, and it's 60 cents. 2 stands for Bubblicious, and it's 70 cents. And 3 stands for Hubba Bubba, and it's 70 cents. Can you have 2 different kinds of gum with the same price? You're telling me, Asia, can 2 different kinds of gum be the same price? Can a Hershey bar and a Milky Way be the same price?
Yes.
That can happen. 3 different kinds of gum can have the same price, all be 70 cents. Okay, so you can have Y's repeat. Are you with me? You can have your Y's repeat. In this case, if the first one stands for Double Mint, and it's 60 cents, and they come in those big boxes, and you take one out, and there's another pack, same size, same quantity. Is the next one going to be 70 cents? They're all going to be 60 cents in that box. You're not going to have 2 prices for the same pack of gum. Does that make sense? Okay, another way to think of it is like distance. If I'm traveling, I can't travel 10 miles and 12 miles in the same amount of time in that given moment. Does that make sense? Okay, so think of the gum. All right, so now let's look at, whoops. We said there's exactly 1 output for every input. Whoops. Is this a function? Everybody.
Yes.
Why?
No extra.
Everybody.
No extra.
No repeated x's. Is this a function?
Yes.
Why? Good. Okay, is this a function? Even though the y's are repeated, that's okay. My gum can be the same price. Okay. Is this a function? Why, Audrey? Because 1 repeats. So in the table, we're looking for repeating x's. In the map, we're looking for 2 arrows out of the same input. Okay, let's look at an absolute value. What this means here in the equation is that x is my input. Okay? Stay present. Thanks. Okay. This is my input. I make my table. I get to choose my input with 2 variables. -2, -1, 0, 1, 2. When I plug it into the number machine, absolute value is going to do what to that -2? Yeah.
Make it positive.
Make it positive. Make it positive. Keep it positive. Keep it positive. Keep it positive. Is this a function?
Yes.
So absolute value is a function. But look what happens when I make y my input. Y is now my input. I'm going to choose my y. We can do the map and you'll see it. I'm going to choose the y's this time. Let's go -2, -1, 0, 1, 2. When I substitute that in, what's x going to be? 2. When I substitute that in, it's going to be
1.
the next one 0. The next one 1. Is this a function?
No.
Not a function. So when y is the input, it's no longer a function. And we can see in the map, we have 2 arrows coming out of the 1, out of that input. Questions? All right, number 1, Julian, is that a function?
Yes.
Yes.
Oh, yeah.
Yes or no?
Yes.
Okay, if you get confused, what I want you to do is just to start making the relation. You know, start listing it. What does this mean? What is the ordered pair, Julian? 0 what?
5, 1, 5, 2, 5, 3, 5.
And then look at it. Do you understand?
Yeah.
Look at it and then make the determination. Don't do it in your head. Okay? 1 is a function. Is 2 a function? Not a function. 3.
Yes.
4.
No.
Good. So now we can recognize from the map, from the table, from the relation. Really, 3 of the same things. Now, the next way to figure out if something's a function is with the vertical line test. Okay, a vertical line test means I'm going to run a vertical line through the graph. And if it crosses my vertical line at any 2 places at exactly the same moment in time, it is not a function. So we can see in this moment, it only crosses at 1 point. As I animate it and run the vertical line through, it never crosses it 2 times at the same moment. So it's a function. Are you guys getting this?
Yeah.
It'll make more sense towards the end. As I run my vertical line, does it pass the vertical line test?
Yes.
Does it ever cross that vertical line at 2 places in the same moment in time? So it passes the test. It's a function. What about this one? Does this pass my vertical line test?
No.
Because it will cross in multiple places. You see that? Let me play it again. It crosses at infinite amount of places. Does that make sense?
Yes.
Look at it. It crosses more than 1 point at exactly the same time. Crosses here, 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 here. I mean, it's multiple. It's infinite. Do you understand? Okay. Next one. Let's go on to this next picture. Does anybody know what this is called? Caleb?
Quadratic.
Okay, it is made from a quadratic, but what's this picture called, Zach? Parabola. Is a parabola a function? It is a function because it actually has a slant to it. It's not vertical. Only if it's vertical will it not be a fraction.
How do you spell parabol?
Parabal. You can see the vertical line. It never passes at more than one point in the same moment in time. Now, here's where it's all going to make sense. Okay? Is this a function?
No.
We can see at any given time it crosses at 2 points. It doesn't pass the vertical line test. Not a function. Is this a function?
Yes.
Yes? This is, by the way, x cubed. This is a cubic function. Okay? It's got a slope to that slant to that slope. So it's not vertical, so it is. What about the next one? Jack McRitchie. Is this a function? Nope. Next one. Function? Nope, not a function. So, is this clear? Okay, you need to stay for this. Let me just show you one more thing. Let's look at the third graph. I'm going to kind of expand it and 1, 2, 3. So if I have something that looks like this, and I'm really kind of trying to, if I made a table out of it, notice what my table would look like. The first point would be 3, 0. The second point would be 3, 1. What happens to that vertical line? 3, 2. When the vertical line, when we list the ordered pairs, what happens in the table? Chris?
The x repeats.
The x repeats. The x repeats. Okay, and then let's take another situation. Hopefully you learned this last year with Miss Cacciatore. Let's take 2 points. 3, 1 and 3, 2. Remember slope? 2 minus 1 over 3 minus 3. Use the slope formula. I get a 1 over a...
0.
No! Not 0.
0,
Oh my gosh. What does that mean?
it's infinite.
It's not... Caleb,
Undefined.
you are breaking the number 1 commandment. Thou shalt not divide by 0. Let it be said, God has said the word. And when you do that in math, God will strike you. So you cannot do that. The world is depending on you to not divide by 0. It can't happen. It can't happen. So, we see that our slope is undefined. We see in our table it's repeated, and it doesn't pass the vertical line test. All the same one. Now, if you don't believe me, the next thing you can do is ask Suri.
What is 1 divided by 0?
Please don't make me divide by 0. That would be like me asking you to grow a third arm.
Okay.
Do you want to do another one?
I can't really say.
What's the other one she does? What's 5 divided? Why does
Let
she
me find it. What is 1 divided by 0?
The answer is definitely...
Let me find it. What is 1 divided by 0?
Imagine that you have 1 cookies and you split them equally. Does each of your friends get? See, it doesn't make sense. So Cookie Monster gets them all. Nom nom nom.
Okay, so Siri says, imagine that you have 1 cookie, you have 1 cookies, and you split them evenly among 0 friends. How many cookies does each of your friends get? See, it doesn't make sense. So Cookie Monster gets them all. Nom 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 nom.
Wait, let's do another one. There's one
Okay. All right, so now the last part to this is really talking about the domain. Okay, so sometimes we get asked the question, state the domain and range. So with number 1, we can easily list the ordered pairs. And then from there, I can state my domain and range. Okay? And so my domain is -2, -1, 2, and 4. -2, -1, 2, and 4. My range is 1, -3, 2, and 2. Now, as we continue on, if you look at number 2, and I really kind of like look at, let's just take some sample points. You've got this, you've got this one right here, you've got this. We can see that since this is going to keep continuing in a horizontal fashion, eventually you will have an X that will fit over here. It's going to hit all of the X values in both directions because this is going to keep continuing. And so if I picked a point here, I'd eventually go over here and then up, and that would be. So for my domain, for number 2, the domain would eventually hit all real numbers on the x-axis. Whereas my range, you will note, I'm never going to hit less than this minimum point here, which is right here. My y's will never go below the minimum of that. So what I can say is y is greater than or equal to, that's a -3. Okay? On number 3, I can state that my range, my domain, now notice, here's a point, here's a point, here's a point, here's a point, here's a point. Let's just, and then all those points in between. So I'm really going to kind of want to use an inequality because I don't want to list all those points. But the minimum x value, since this is a -2, comma, -1, and the other one is +1, 2, comma, 3, we can use our inequality to state that I can do an in-between. X is less than, or is greater than or equal to -2 and less than or equal to +2. And the next range, the range would be y is less than or equal to -1 or greater than or equal to 3. And now you're going to kind of have to do the same thing. Now try number 4. I've gone so long. This is such a long video. Pause it and now check your answers. And that's the lesson.